Did you know that with just one old refrigerator compressor, you can build a powerful vacuum pump that performs just as well as industrial machines, all while saving a ton of money? Sounds crazy, right? But it's totally doable. In today's project, I'm going to show you how I turned a junk fridge part into a super effective vacuum pump that I use for degassing epoxy resin. If you've ever struggled with annoying air bubbles in your resin projects, this is the game changer you've been waiting for. It's simple, budget-friendly, and surprisingly powerful. Let's dive in. When working with epoxy resin, air bubbles are your #1 enemy. They can ruin your project by leaving pits, cloudiness, and an overall poor finish. A vacuum pump solves this problem by pulling all the bubbles out of the resin before it cures, giving you a flawless, crystal clear result. But here's the catch: commercial vacuum pumps can be seriously expensive. That's why I decided to get creative and repurpose an old refrigerator compressor to build my own DIY vacuum pump. It's powerful, effective, and costs just a fraction of what you'd pay for a store-bought one. I ran into a pretty frustrating issue. The compressor was running, but it wasn't pulling any vacuum at all. The vacuum gauge didn't move, not even a little. This is actually a common problem. The culprit: a worn-out check valve inside the compressor. Inside every fridge compressor, a Ka block, there's a small check valve that helps maintain pressure by allowing air to flow only in one direction. Over time, this valve can wear out or get stuck. When that happens, the compressor runs, but it pulls absolutely no vacuum because the air just flows back in to fix it. I had to cut open the compressor casing. Important warning: there's oil inside the compressor, and there may still be refrigerant gas remaining. Make sure you fully discharge any leftover gas. And be very careful with sparks when cutting the metal housing. Here's the check valve. It works kind of like a reed valve, a thin metal flap. After years of use, the metal flap can deform or wear down, so it no longer seals properly. That means air gets pulled in and just leaks right back out. Here's how I fixed it. Sanded the valve seat to make it perfectly flat, ensured the reed metal flap sits flush and seals completely when closed. Note: opening a compressor like this is for DIY enthusiasts who are confident with tools and mechanical systems. If you're unsure, it's best to ask a refrigeration technician for help. But don't worry, fridge compressors are incredibly durable. Once repaired, they can run like new for years. Since the original compressor's motor winding was damaged, I decided to replace it with a 350W DC motor to power the compressor externally. This upgrade gives the compressor a new lease on life. It actually makes it even more powerful than before. By driving the block with an external motor, I can control the speed more precisely and boost performance beyond the original design. Next, I'm going to build a vacuum chamber for the setup. I'll be using a 10mm thick acrylic plexiglass lid for visibility and strength, along with a vacuum gauge, AB epoxy adhesive, a shutoff valve, and a bunch of other fittings and parts to complete the build. The goal is to make a chamber that's airtight, strong enough to handle deep vacuum, and easy to use when degassing epoxy resin or silicone. For the vacuum chamber itself, I'll be using a small cast iron pot. These pots are actually pretty affordable, and cast iron is super sturdy, perfect for handling vacuum pressure. I don't need a big chamber since most of the epoxy pieces I work on are fairly small, so this compact size is just right for me, hopefully. The pot will be airtight once everything is sealed up properly. Now that the vacuum pump is ready, let's talk about mixing epoxy resin, one of the most important steps in the whole process. If you get the ratio or mixing technique wrong, the resin might not cure properly. You could end up with sticky surfaces, cloudy finishes, air bubbles, or even yellowing over time. Different types of epoxy resin require different mixing ratios. For example, 3D deep pore resin mix ratio is 2 parts A to 1 part B standard. Resin, usually 1 part A to 1 part B. Always read the manufacturer's instructions carefully before mixing. If you add too much hardener, the resin can turn brittle, crack, or yellow quickly. If you add too little hardener, it might never cure at all. While mixing, a lot of air bubbles will naturally form. And that's exactly why we need the vacuum pump. Here are a few quick tips to reduce bubbles. During mixing, stir slowly and gently. Don't whip or shake it. Let the resin rest for a few minutes after mixing to let bubbles rise to the surface. Work in a room with stable temperature and low humidity for the best results. If you mix the correct ratio, stir thoroughly and use a vacuum pump to degass the resin. You'll get a crystal clear, bubble-free finish, perfect for any resin art or casting project. That's exactly why I built my own vacuum pump in the first place.